if you eat a lot of eggs, you might have a niacin deficiency. So you see this in bodybuilders, excessive raw egg white intake. Avidin is going to bind onto the biotin, so you're going to have less biotin, causing myalgias, anorexia, and macular dermatitis. It's like a rash on your extremities and your face. Lactic acidosis as well. So biotin is a cofactor that is going to cause a lot of these symptoms in your body. And so bodybuilders eating large amounts of raw egg whites are going to have fatigue, muscle pain, dry rash, because they cannot turn pyruvate into oxyl acetate, because that is a biotin dependent reaction, and so they're not going to be able to do it. Okay, some other answer choices that you might see, and this is where it gets more high yield and importance, because biotin, sure, it's cool, important enzyme for carboxylase reactions, but there are also some other ones, right? So there's glucose 6-phosphate to ribose 5-phosphate. Okay, so that's going to be our pentose phosphate pathway. So I'll put that here. It's going to be our pentose phosphate, and so we have a vitamin, it's niacin, B3, and what happens there is that's needed for our oxidative burst in our G6PD deficiencies. And so if we don't have niacin, we don't have B3, then we can't create our NADP, and so we can't have that antioxidant defense. Next one is going to be our vitamins like thiamine, riboflavin, niacin, and B5 here. I'll put it right here. This is pyruvate. So our pyruvate is going to be transformed into acetyl-CoA for the pyruvate dehydrogenase complex. For that, you need a whole lot of stuff. You need all that thiamine, riboflavin, and niacin, all that stuff. This is seen in Wernicke's encephalopathy, thiamine before glucose. You got to give the person, and also mitochondria. So if somebody's drunk, give them thiamine. It's central to linking the glycolysis to the TCA cycle. So you can get that acetyl-CoA, so you can launch that pyruvate dehydrogenase complex. Okay, next they might ask you about this one, the pyruvate plus glutamate equals alanine plus alpha ketoglutarate. All right, so that's an important reaction as well. What's involved in this one is B6. Okay, so this is a transamination reaction, a key an amino acid metabolism in the urea cycle. So you have your weird ALT, AST, and also your isoniazid effects and B6 deficiencies and neuropathies. All right, so this is the creation of alanine. Okay, so that alanine is going to be your B6. Just to recap, glucose, our glucose to ribose 5, our glucose to ribose 5 right here. This is going to be your oxidative burst in the pentose phosphate. PPP, I like to think of this 5 as just like a lot of P's, even though there are only 3 of them. But I don't know, it helps me. Ribose 5, phosphate, PPP. And here we have pyruvate complex, and that is going to be your Wernicke's encephalopathy, and your the way you should think about it is your pyruvate dehydrogenase complex. So acetyl-CoA can't be produced, so the pyruvate dehydrogenase complex can't be created, and so you got to give them thiamine, and that's mitochondrially going to affect the mitochondria. Okay, and so next one is going to be our pyruvate to our oxyl acetate. That's our correct answer for biotin is needed for that, and it's gluconeogenesis and also TCA cycle association. So avidin, raw egg whites, that's what you should be thinking of for your biotin deficiencies. And then, of course, our last one is going to be our succinate into malate. This is our oxyl acetate TCA cycle. Okay, so what is going to be associated here is we have our riboflavin and our niacin, and these guys are going to be important for the TCA cycle to run. So your malate to oxyl acetate. So succinate, malate, oxyl acetate, your TCA cycle, riboflavin is needed, also niacin as well. Okay, so just in sum, B1 to B7, these are going to be your TCA players. You got the B1 transketolase, pyruvate dehydrogenase. B2 is going to be your FAD to succinate. B3 is going to be your NAD to NADPH, your pentose PPP, pentose phosphate cycle. So your pentose phosphate pathway is going to be involved with your B3. And then B5 is going to be your coenzyme A, and B6 is transamination, and B7 is carboxylase, so your biotin. Like in this question, in B12, this is methyl transfer, so DNA synthesis. Okay, a lot of vitamins. Wow. We'll see you in the next video.